Hello, viewers. Welcome to another episode number 33. Hooray to you for watching up to this stage. We are taking a scale drawing and rate, a scale of a map. So there's a question we want to look at. So the model of aircraft is made on a scale of 1:20, meaning 1 centimeter on the model represents 20 on the aircraft. So if the aircraft is 25 centimeters long, the actual aircraft has 25 centimeters long as the length. So how long is the model? The model is the measurement on the paper, the smaller measurement. All right. So if the area of the wing surface on the model is 0.22 meters square. So what is the area of the aircraft, the wings, the main aircraft? Then the aircraft carries 30 meters cube of fuel. So what is the capacity of the model's fuel tank? I believe you are seeing the dimension. The scale is always on the ground and a model or the map. The map and that of the real thing, the actual thing. So this scale given to us here shows that this is on the model and this is on the aircraft itself, the actual diagram. So now picking the first information, which we know that a scale is given as 1:20. That simply means 1 centimeter on the model equals to 20 centimeter on the aircraft. So now what do? We are looking for if the aircraft is 25, so the actual length, so length of aircraft. The length of aircraft, so you're looking for the length of model. So length of model is going to be y. We don't know. So now this ratio is the same as the ratio of the two measurements. So we can write that as a proportion. So by proportion, we have 1 we can have 1:20 equals to this is on the ground, so this is on the model, so y is to 25. Don't forget, not because I wrote 25 first before y, it should come in that direction. 1 is on the model, the length of the model is y, so that will correspond. Then the actual length of the aircraft will also correspond. So let's write this as a fraction. 1/20 equals y on what? 25. I believe we can cross multiply to have 20y equals to 25. 1 times 25, cross multiplication. So what do? We divide by the 20 as the coefficient. So divided by 20, divided by 20, y will be equals to. So 25 divided by 20 will be 5/4, and that will give us 1.25 centimeters. So in this case, the length of the model. So the length of the model is 1.25, whilst the actual length of the aircraft will be 25. So that is per the length. So the next thing is to find the area. So let's see how we can do that also. Alright, so pertaining this, if you remember in our introduction lesson, we mentioned that the scale of an area. So we can say that scale of area equals to 1:n squared. 1:n squared, and this n is our 20. So we have 1:20 squared, which is the same as 400, right? 20 times 20. So now what do we need? They said if the area of the wing on the model, so the area on the model, so area of model is 0.22 meters squared. Okay, the area on the model. What is the area of the aircraft? So we need to find the area of aircraft, which we don't know. So in this case, don't forget, this one representing the area on the model. This 400 represent the area on the aircraft. So model, aircraft. So by proportion, we can say 1 is to 400 should be equals to area on the model is 0.22 is to area on the aircraft. Why? It must correspond. The first one is on the model. So the first ones will be on the model. So that will be 1, 400 equals to 0.22 divided by y. What do we do? Y will multiply straightforward to give us 400 times 0.22. Don't forget 0.22 is just like 22 divided by 100. 22 divided by 100. That 100 will divide the 400 and cancel. Remaining 4. 4 times 22. That will give us 88. So we're going to have 88 meter square. So therefore the area of the aircraft is going to be 88 meters square, whilst the area on the model will be 0.22 meters square. I believe you get the concept. Good. The next is to find the volume. Okay, when they come to capacity, which is the volume, it is also having the scale of volume equals to 1:n cube. If you watch our first episode, you see the formula for the length, the area, and the volume as we derived, as we've stated. So now the scale of volume is going to be 1 centimeter or 1 meter cube, whether a centimeter cube on the model equals to the n cube on the airplane. So this is going to be 1:20 to the power 3. That simply means 20 times 20, that's 400. So we have 400 times 20. So that is also going to be 2 times this, 800 times 10, that's what? 8,000. So 1:8,000. So the scale is known. The aircraft carries this. This is the main aircraft carrying a fuel of 30 meter cube. What is the capacity of the model? So we need to find the capacity of the model. The model is the one representing this. So you can see capacity of aircraft is given as 30 meter cube. So let's see. The capacity of what? The model. Let that also be y. So in this case, we can write that by proportion. We can see that picking 1:8,000 equals to model, airplane. Model, y is to airplane, 30. So we can write this as a fraction, So 1 divided by 8,000 should be equals to y divided by what? 30. I believe you see we can cross multiply to have 8,000y equals to 30. What do? We divide by the 8,000 since you're looking for y. So divide here by 8,000, here by 8,000. So y will be equals to, this, we'll cancel this. You're left with 3 divided by 800. And that will give us, we have 0.00375 meter cube. Therefore, we can conclude that the capacity of the model's fuel tank will be 0.00375 meter cube. All right, I believe we are able to group all the aspects of scale drawing in this question. Complement with the first 2 episodes. you are able to understand how to find the actual length, actual area, actual volume when the volume on the map or vice versa is given unto us. Thanks for watching. Like, share, and comment. Bye bye.